Understanding vector algebra. Bearing angle. Let's understand what is bearing angle. You'll come across this term in a lot of problems, especially when you are dealing with navigation, whether it's aircrafts or ships. Bearing angle is measured from north in clockwise direction, right? With the help of this example, I will show you how to find bearing angle, right? So here we have three different vectors shown. So here this vector is PQ. Let me give a direction here. So this is PQ for us, and this is MN, let us say. It is pointing in this direction. And ST, let me point that direction. Let us give direction to each of our vectors, right? So we have three vectors here, and we'll try to understand how to find bearing angle for these vectors, right? You know vectors have direction and magnitude. Magnitude, you all now have practice questions. Magnitude is finding distance between the two. Now that is, you can find what is delta x, change in x position, square it, change in y position, square it, add them and square root to get the distance. That means apply either distance formula. So let me just write down distance formula for you here. So we'll write distance formula, which is x2 minus x1 whole square plus y2 minus y1 whole square and square root, right? So that will give you magnitude of your vectors, correct? Now our primary concern here is to find direction, right? The other component of a vector. Now how to find direction? So one way is to write the direction in terms of bearing angle. Now bearing angle is always measured from north and clockwise. I have told you. Now let's see how to calculate this, right? To calculate, let's start with the first one, which is PQ. Think like this, that we have a coordinate plane here, correct? So what we will do is we'll find this angle, the angle which PQ makes with the horizontal. We'll find that angle first. It is easy to find since we can use trigonometric ratios, right? Tan theta, you remember? So we'll first do tan theta, and we find tan theta, and we are doing direction for our vector PQ, right? So the vector is PQ for us, and let me define PQ. The initial point for PQ is minus 5 minus 1. So it goes from minus 5 minus 1 to Q, which is 2 and 4, minus 2 and 4, right? So that is our vector PQ, right? So that is the tail part of it. Let me write T here for tail, just to remind you, and there's the head, right? Now, tan theta will be difference in y value divided by difference in x value. Let's write like this. Difference in y value divided by difference in x value. Y value difference is 4 minus minus 1. 4 minus minus 1. And x value difference is minus 2 minus minus 5. 4 minus minus 1 means 4 plus 1, which is 5. And 5 minus minus 5 means minus 2. Minus 2 plus 5. That means 3, right? So that is what we get. You can check. Change in y value is 1, 2, 3, 4, 5. Simple. X, 1, 2, 3. Right. So we got this. Now from here, theta is equals to tan inverse of 5 over 3 within brackets, and get the answer using calculator. So we'll do second function, tan inverse within bracket 5 divided by 3 bracket close equal to 59.03. So we can write this approximately as 59 degree, right? So all the answers are in degrees. Now if this angle is theta, then how much angle does it make with the north clockwise? That is what you have to find. Do you understand? As you can see, total is 90 degrees, right? So the bearing angle is how much? So bearing angle is 90 minus 59, right? 90 minus 59 degrees, right? So it was 60, 30, so it is 31 degrees, 31 degrees. So that is the bearing angle for PQ, correct? So that's how you find it, correct? I hope you understand how we did it. Let's do for ST. Now bearing angle for ST is, it is horizontally going east. So think like this. If it is going east, or we can make our coordinate plane here itself. So that is my y-axis. This is axis. It goes towards east. What angle does it make with north? 90 degrees, right? So clockwise, it is 90 degrees. So we say bearing angle is of 90 degrees. But remember, we have to write 0, 90 degrees. Always 3 digits. So let me correct that part also. 0, 31. So 0, 90 degrees is the bearing angle for ST. Now let's do the same calculation for the vector NM, right? Now here in NM, let's find this angle. So tan theta is, so we can write theta equals to tan inverse. We are doing shortcut. We'll follow exactly the same method and then find, right? This is for MN. So I'm using MN vector and finding bearing angle for this. Tan inverse of, let's complete this triangle, right? So it is rise of 1, 2, 3 divided by 1, 2, 3, 4. 3 over 4, right? That gives us the value. Let's use calculator. Second function, tan inverse within bracket 3 divided by 4 bracket close equal to 36.869. Let's say 37 degrees, right? So we get approximately 37 degrees. Now since this is 37 degrees, how will you find the bearing angle? The bearing angle is measured always from north, right? So that means the angle which you have to report is this much. Going from here like this, that is the angle. Do you see that? So basically it is 270 plus 37. That is one answer. Or you can calculate how much is remaining and take away that much from 360, right? So you can do like that. So what we will do is, we will write our bearing angle as (270 degrees plus 37 degrees), right? That is kind of easy, right? You know this is 270 and that much more, right? 270 plus 37 will give us 7, 10, 307 degrees, right? So we have a bearing angle of 307 degrees for the vector MN, right? So I hope you understand how to calculate bearing angle for all these, right?